we want to integrate 2x sine x with respect to x. This doesn't fit a basic integration formula, and integration using substitution doesn't work either, so now we'll apply integration by parts. Here's the formula for integration by parts. We'll let part of the integral equal u and the other part equal dv. Once we choose u, we'll differentiate to determine differential u, and once we choose dv, we'll integrate to determine v. And the guidelines tell us to select a u so that differential u is simpler than u, and to select a dv that is easy to integrate. And for this example, that may not be a lot of help because both of these are easy to integrate and differentiate. But if we did choose u equals 2x, differential u would be simpler. It would just be 2 dx. And if we selected u equals sine x, differential u would be cosine x dx, which is not any simpler. So that means that dv is going to have to be sine x dx. So now we'll have to integrate to determine v. Well, the integral of sine x with respect to x would be negative cosine x. Now that we have everything, we can apply the integration by parts formula. And hopefully the integral of v du is going to be easier to integrate, and I think it will be. So the original integral is equal to u times v. Well, here's u and here's v, so we'll have negative 2x cosine x minus the integral of v du. Well, here's v and here's du, so we'll have the integral of negative 2 cosine x dx. So we'll factor the negative 2 out, and we have cosine x dx. So we'll have negative 2x cosine x. This will be plus 2 times the antiderivative of cosine x, which is sine x, and then plus c. And we could leave it like this, but let's go ahead and factor a 2 out. If we factored out a positive 2, we'd probably put sine x first, minus x cosine x, and then plus c. So this would be our antiderivative using integration by parts. In the last example, we'll take a look at using integration by parts twice to determine an antiderivative. I hope this was helpful.